The row cumsum provides a way to do a cumulative summary across rows. In this first example, I've created a very simple data table with the values 1, 2, 3, 4, 5, and so forth all the way up to 10. I pipe its output to serialize, and that's because row cumsum does require the use of serialize. If you can envision it, under the hood it needs to use the same prev next functionality we looked at earlier in this module. When I execute this, you're going to see we have our values of A, 1, 2, 3, 4, 5. Then I have my cumulative summary. For the first row, it takes the value in A, adds it to the cumulative summary in the previous row. Well, there was no previous row, so that's a value of 0, so 1 plus 0 is 1. On row number 2, it takes the value of 2, adds it to what was in the cumulative summary on the previous row, which was the value 1, and we get 2 plus 1 equals 3. And it just repeats this for each row. So in this next example, let's add up the number of bytes we've received according to our performance counters. So I've got my from time and my through time. I'm then going to pipe in where time generated between. I got my object name and counter name. I'm going to do a summarize bytes received per hour equals sum of the counter value, and I'm going to bin these up by computer and time generated. I'm then going to sort this by my computer and time generated. Sorting is very important. We need to be able to make sure the data goes in the correct order. And then finally, we're going to serialize it to use row cumsum. We're going to tell it we want to accumulate on bytes received per hour and put that into bytes received per current hour. So you can see in my output, I have my bytes received current hour. We start off with 0 plus the first row, 901,000, to give us current hour 901,000. Then we'll take our 901,000 and add it to the second row, 1,036,000, to give us a total of 1,937,000. And we just keep repeating that. Row cumsum has a second parameter called reset. Reset takes a true or false condition to determine if it should reset the counter. In other words, should I start counting all over again? Now we can use this to do some pretty cool things. In this example, I'm going to use it to create a row number counter. Here I have a very similar query to what you just saw. We're getting our time generated in a time range. We're going to look at percent processor time to get the total for it. I'm then going to summarize my percent CPU time by computer into bins, sort it, and then I'm going to add a variable called temp. Temp equals 1. I'm then going to use extend to create a new column called row num partitioned. Row num partition is going to equal row underbar cumsum. It's going to accumulate on my temp. The true-false condition that will cause this to change is when the computer for the current row is not equal to the computer on the previous row. And then I use project away to hide my temp counter. I think when I run this, you'll get a better idea of what's going on. In the output, you can see on the first row, AZ test, my row num partitioned, well, there was no previous value, so temp value of 1 plus 0 equals 1. On the next row, I then have my row number previously was 1. I add it to the temp value of 1 to give me 2. I then repeat that for 3 and 4. And then I see that my computer name has changed. Suddenly, I'm on AZ test 2. Well, we said when the computer name is not equal to the previous one, reset, so now my row num partition is back to the value of 1. Creating a row number was a good way to illustrate this clearly, but you could use this to create running totals and do resets based upon any type of grouping you want. Here we used computer, which was natural. You could also have used a counter name or something similar.